Hello, this is Mr. Manley. In this video, I'm going to look at a three-variable linear system that does not have a solution. If you've watched my previous video on three-variable linear systems, you'll recognize the method that I'm going to use. So I'll jump right in. The first thing that I'm going to do is number each of the equations. Then I'm going to choose two equations to combine and eliminate a variable. Looking at this, I think it'll be fine just to take the first two here and eliminate the x. And I'll indicate that I'm working with equation 1 and 2. I'm going to multiply the first equation by 3 so that the x's here will match. So there's the first equation multiplied by 3, and then I'm just going to bring down equation 2, and since the x's match, I'm going to subtract the second equation from the first equation, and I get 5y minus 10z equals 10. Now the next thing is, since I used equation 1 and equation 2, I have to use equation 3, and I can combine that with either of the other two. I like 2x, I like the idea of multiplying the first equation by 2 so that I can match up the x's and eliminate that. So I'm going to multiply, I'm going to work with the first equation, and I'm going to multiply that equation by 2. And I'll bring in the second equation, and we are ready to subtract these equations from each other to eliminate the x term. And that'll give us 0x, and then the y and the z term. Next thing is that I want to combine this equation with this equation, and I made an error on that equation. So right here, that should be -4 minus 6 is -10. So let's make that change. Okay, so there's the minus 10z. Now combining these two equations, I will bring down this one, and then I will bring down this other equation. And I noticed before I brought these equations down that I had this match here, 5y and 5y, so I didn't need to operate upon them. And now that I have both equations, I will subtract the second equation from the first equation. And what do I get? I get 5 minus 5 is 0, and I get -10 minus -10 is 0. So I've got 0, and then equals 8 minus -2 is 10. And 0 does not, in fact, equal 10. So that's does not equal, and when we end up with a non-true statement like that, we say no solution. So we were looking for the coordinates, right? We were looking for the x, y, z coordinates that satisfy these three equations, all three, and no such coordinates exist. Looking at that visually, I have three equations in three variables. When I have an equation in three variables, that represents a plane. So I have three planes with these three equations, and those three planes in the picture here, hopefully you can see these three planes are parallel to each other, so they never intersect, and that's what we're looking for here. In addition to looking for the coordinates which would satisfy all three of these equations, visually we're looking for the place where the graphs of these three equations intersect, and there is no place where they intersect. So that is a three-variable linear system with no solution.